Yeah. So we are group 9 DevDocs. Myself, Hima, Saksham, Meldon, and Tejas are gonna demonstrate the project that we built as part of DevOps assignment 2. So the project is bookstore application. The application is built upon the technologies Java, Spring Boot, Maven for the backend, HTML and JavaScript in the front end. The DevOps tools that we have used for this product are GitHub, GitHub Actions, Docker, Prometheus, and Grafana. So coming to the complete flow of the project, we have built the project and pushed the code for the project onto the GitHub and performed some GitHub action workflows, pushed the whole project as a created a Docker image for the whole Spring Boot application. Now let us see the demonstration of the project.
Okay, so this is basically book space application. So we have created the REST APIs, and here we are just consuming the REST APIs. So add is to just add a book. Uh, Here we can add the books. Uh, Here we can update the books, and we can search the books by the name, and we can display the books, and we can remove the books. Coming to the form.xml, that is our Maven. So this is basically a project management tool for this bookstore application, and we have used the Maven for this. And this pom.xml represents the dependencies and all, includes the dependencies and all. Over to Hima for the Git and GitHub actions.
Coming to the GitHub, so we have used GitHub as the main DevOps tools to keep all complete code for both for the backend and front end. So we have created a repository named Bookstore. So all the code for front end and the backend resides here in this repository. So coming to the GitHub Actions, in GitHub Actions, we have the provision to create the workflows. And here we can see here we can see there are these workflows run whenever there is a push onto the branch master. So before that, let me show you how this workflows work. There is a file called maven.yaml which we have defined. So on the name bookstore, on the push to the branch master or on the pull request to the branch master, the workflow that we have defined on GitHub Actions will perform the following jobs. So it will run on the operating system Ubuntu and have some actions to check out at V3 and set up the JDK and build the Maven and build and push the Docker image. These are few jobs that we have mentioned in the workflow. Here we can see in the front end. So whenever there is a push onto the master branch, here I have updated the README file a few minutes ago. And here when this README file was updated, this build was run, and all the steps that were mentioned inside the build, like setup job, run, setup JDK, build Maven, Docker building and pushing the Docker image was also performed. So as part of building and pushing the Docker image, which is the next important DevOps tools that we have used, here I will define you the task which is under the build and push Docker image. So we have defined the Docker ID that we are using. Docker Hub, we have created a account on Docker Hub, and it has the Docker ID Himabit. So it will we have defined the Docker image name that we want, and we have defined here the username and password, so that there is a section called secrets in GitHub where this Docker username and Docker password has been saved. So from there, GitHub fetches these credentials and logs in into the Docker Hub and creates the Docker image. So once the push is done on the master branch, the Docker image gets updated on the Docker Hub. So here in the Docker Hub, you can see under the Docker ID Himabits, the bookstore image has been created, and you can see here the Docker image has been updated a few minutes back when the push was done. So we can see the push was done. The push was performed few minutes ago, and so as the Docker image has also been updated few minutes ago. So one can use this command docker pull to pull the Docker image onto the local, and also run the Docker image using the command docker run with the image name. Also, you can log in, get into the Docker desktop and view your Docker image after you pull the Docker image from the Docker hub. Yeah, this is the demonstration as part of Docker, and next I would hand it over to Tejas for demonstration on Prometheus. Thank you.
So coming to Prometheus, Prometheus is a open source monitoring tool which scrapes your application and gathers metrics basically from the HTTP endpoints. So to download Prometheus, you go to prometheus.io. Once you download it in your Spring Boot application, you have to add two dependencies. One is actuator dependency, another is a micrometer, which is a Prometheus dependencies. Then in the Spring Boot application, you go to application properties and expose the endpoint. So Prometheus can scrape these endpoints, your HTTP endpoints of application. Once that is done, you go to Prometheus YAML file. In that you define some properties like job name, which target that is at which port it should run, what is the port of your application, and what is the scraping interval. Once that is done, you will turn on the Prometheus server using by going to that Prometheus uh, software that you downloaded. It just execute prometheus.exe. It will turn on the Prometheus server on port 9090. If we go to that port in our browser, you will see the Prometheus dashboard. This is the Prometheus dashboard. It has many queries. We will look into HTTP request for now. So if we search for HTTP request we and execute that query, we will see like these are some queries that has been run by the application like 71 and 47 post request. So this is how Prometheus scrapes the data, and you can also see the graph from Prometheus in the graphs tab. And that's how Prometheus works by scraping your data. Next, we will see on the Grafana part by Tejas.
Coming to Grafana, Grafana is an open source analytical visualization web application. So we use Grafana to create dashboards. Grafana mainly takes the data from Prometheus and makes charts out of it so that the user can monitor the health of the application which is running. So to set up Grafana, we need to download the Grafana server. We can either have the bins binary for download or the Windows installer. So after downloading that, we need to start the server using running it over PowerShell. So once we run the server, the Grafana application will load at localhost 3000. Yes. So when you come to this page, you'll get an option to create dashboards. So while configuring the dashboards, we set the data source as Prometheus, which runs on localhost 9090. Then we skip into our dashboard. As you can see, our dashboard provides metrics such as uptime, start time, the heap used, the CPU usage. We can also get alerts based on, for example, if the CPU usage is above a certain limit, we can trigger an email to the user, but that would require a separate SMTP server for it. We also have statistics on Java memory. For example, if you create an object, it will go to the hidden space. If it survives for a bit longer time, it will go to the survivor space, and then it will jump to the old gen if it stays there persistently. Then we have the number of classes loaded over time. We have buffers. We have number of threads which are running in the background. Then we also have statistics which are regarding garbage collection. So as Meldon mentioned about HTTP requests, we also have the number of requests that are posted or uh, get from our website. So here you can see the get all books is called 71 times. The actuator endpoint is hit 1926 times. We also have response times for each of these methods. We also have log statistics. For example, if the Spring Boot application has a line called logo.info, we can see how many times that is being hit also. So in the end, let me show you. You can notice that now the get for get all books is hit 71 times. So using Postman, I will try to have the request execute for 15 times. So if you'd remember, Meldon told that for every 5 seconds, the website is scraped. So let's wait for 5 seconds. And if I hit on reload, yeah, now you can see 71 has changed to 86. So this is how Grafana is used as a visualization tool. Prometheus mainly helps in monitoring the service. It tracks the data using HTTP endpoints. So this is our demo. Thank you, everyone. We are open to questions if you have any.